So with that, I would like to invite our first speaker, Akshay Saini.
So first of all, before beginning, let's give a big round of applause to all the organizing team of NG India for organizing such a wonderful conference. And it's really an honor to come over here and speak in front of like amazing developers like you. Right? Thank you, DJ and the team. I don't know where he is right now, but thank you for organizing this. It's really a great honor for me to be coming over here and speaking in front of you all. Amazing developers. Yep. So to begin my session, I would like to start with asking you a few questions. Okay. So, can you tell me what is the most hated programming language in the world? And what's the most loved programming language in the world? What is the most popular programming language in the world? So, when it is the most loved, the most popular programming language, then why do people hate JavaScript so much? So the only reason is because they don't understand JavaScript. Once you start understanding it, there is no way you cannot you can hate it, right? You know, in 2007, Jeff Atwood, co-founder of Stack Overflow, said, any application that can be written in JavaScript will eventually be written in JavaScript. Right? And after 15 years, right, that statement still holds true to large extent, right? JavaScript is such a beautiful language that it's present everywhere, isn't it? The smartwatches you wear, your light bulbs, your robots, Web3, right? JavaScript is like everywhere. It's this beauty of this language that has brought it so far, right? I feel it's the most beautiful language in the world, right? And you know, in a way, right, we kind of work on Angular, we work on React, we work on different frameworks and library. We are kind of separated by these frameworks and libraries. But in a way, we are connected by JavaScript, isn't it? Right? We are united by this amazing language, JavaScript. So JavaScript is love, and I feel that we don't give it the love that it actually deserves, right? Don't you feel so? So a big round of applause for JavaScript also. Because if we are sitting over here, if you are here in this room, right, that means JavaScript has definitely played some role in your life, isn't it? So it does not get the love which it deserves, but it should, right? And if you are a really great JavaScript developer, then you might have to struggle in your career also, this type of struggle. So with this, let me begin with a little technical round, right? I mean, start with something technical. So JavaScript is a synchronous single-threaded language, right? And everything in JavaScript happens inside an execution context, right? And there are two types of execution contexts. Can you tell them? So one is the global execution context, and the other thing is functional execution context. Anything, whatever code you write, runs inside these execution contexts. And it is the job of the JavaScript engine to build this, spawn this execution context, and along with that, it does a lot of other stuff. One of that thing is creating a this variable, a this keyword, along with each execution context. And my friend, this keyword, it confuses so many developers out there, right? So in this 15-20 minutes of session, let's understand this. Let's try to see what actually is happening a little bit behind the scenes. I know that, okay, a lot of you would already know a lot of this, but it's my take on it. right? To tell you a little bit more about how it works internally and a little behind the scenes, right? Let's do that. So, as Linus Torvalds says, talk is cheap, show me the code. So, I won't be wasting much more time here. Okay, it's already 9:30. So, I would be directly jumping onto the code, the same VS Code editor, the same browser, right? And let's go to that and write some code to see how this is, right? So, anyone of you, can someone tell that what is the shortest JavaScript program you can write? Huh? Huh? No, not console.log. So the shortest program you can write in JavaScript is an empty file. So you would say that, Akshay, are you kidding me? But actually it is. The shortest program in JavaScript is an empty file. You would say there's nothing happening there. But it's not true. Even when you load an empty file, right? JavaScript engine does a lot of things behind the scenes. When you load this empty file, there are a lot of things which JavaScript engine is doing behind the scenes inside the browser. So let's try to see what it does, right? For that, let's just go to sources and let me put a debugger over here on the first line itself, right? Are you able to see first of all the screen? Okay, cool. So I am putting the debugger right in front of the first line. That means nothing has been executed yet. And let's stop the program there and see what happens behind the scenes, right? Many of you wouldn't have seen this happening behind the scenes, right? But let me tell you what happens behind the scenes. So if I refresh the page, see. Now what happens? So JavaScript engine, as soon as you load any piece of code, any JavaScript file, right? JavaScript engine creates a global execution context, right? And what happens? It creates a global execution context and it puts it inside the call stack. Here you see anonymous, right? This is the global execution context. Along with that, what it also does is this thing you see in the right hand side, right? Global. It is the memory space which it has created. And window, of course, right? It created window, right? If you go over there and if I write window over here, right, in console, where does this come from? I did not write it. Where did it come from? So, whenever you load any JavaScript file, JavaScript engine is doing a lot of work. It is basically creating what? The global execution context. The second thing, it is setting up memory space. And it is also creating a reference to a keyword, special keyword in JavaScript, which is this keyword. If I see, what is this right now? It is again the window, right? What is window? Window is a large object which contains a lot of properties and methods. So this, in the global execution context, is exactly similar to Windows. If I write here, this is exactly same as Windows. It's true. So this was about the global execution context. What was the second type of execution context? Functional execution context. So let us see, okay, and let's also see, right? Let's write over here and see what it prints, right? In the global space, the first line of code, if you write console.log this, let me remove the debugger, go to the sources and remove it. If I run this code, right, if you go to console, you can see it is window, right? Now let us see what happens if I put the same statement inside a function, right? Let's create a function x and put the same statement console.log this and also create a variable inside this function. What happens when you execute this x? When you invoke this function x like that, what happens actually? JavaScript engine, what does JavaScript engine do at this point of time? What does it do? Sorry? Yeah, kind of. And what it does? It creates a, yes, it creates a functional execution context. As in when you invoke it. So see how it happens is, I'll show you behind the scenes also. You would be amazed to see that. Okay. So let me just save the program here, right? So what will happen is, as soon as this program runs, right, this full code, a global execution context is created, pushed inside the call stack here, right? You would see it coming over here, and then as soon as we will invoke a function, a functional execution context will come and will be pushed inside the call stack. That will happen twice. Let's see it slowly happening. Okay. So let me put a debugger, refresh the page. See, now you see anonymous, right? Here is the global execution context, which went inside the call stack, and as soon as the control moved to line number 5, it called the function X, and a functional execution context X was created, right? And it was pushed inside the call stack. So right now the call stack has global execution context and the execution context of X. And with each of these execution contexts, JavaScript engine is also creating a this keyword. For anonymous, for global execution, for global execution context, that this keyword was what? Window. And it was this global memory. And if you see in the local memory of this function X, we see A as undefined. Why? Okay, we haven't moved the control yet. Let's move to the next line. See, it was undefined, now it turned out to be 10, right? So A is already there in the memory space. And there is one more thing, which is this. We did not create it. JavaScript engine did it for us. And it is again, as you see, over here is window. Right? So what we saw from these two examples is that whenever an execution context is created, right, this keyword is definitely created. Isn't it? And in these two cases, we saw that it is pointing to the same variable or the same object, which is window, which is the global object. And you know, whenever I say window, that means the global object. For Chrome, it is window, and for Node, it could be different. For some other place, some other JavaScript engine, it could be something else. It depends on where your code is running. Right now, it's browser, so it's window. In Node, it can be global or something else. But it is sure that any piece of JavaScript runs, a global execution context is created, and a global object is also created by the JavaScript engine. Okay, so let's hurry up and let's see more examples now. Okay, but right now we saw that okay, this was only window when we logged it outside, and inside function also it's the same. But can it be different? Okay, font size. Okay, let me increase it. Now is it visible? Okay, good now. Back. Yep, cool. So yeah, so can it be different than window? Is the question. Yes, I'll show you a few examples, and now pay attention. Now comes the main part. I think most of you would already know this thing, but now I'll show you a few nice things happening behind the scenes in JavaScript that a lot of people pull their hairs when they see that. So suppose if we create an object, right? If we create an object, okay, let's call it as let's give it a property B20, right? And suppose if I add this function X to this object, right? What I am doing is I have added that function X to that object, and now if I call this X like this, obj.x, what would you see? You would see the object, right? So the same function X, when I called it like this, right, and I call it obj.x, the same function behaves differently. How? It behaves differently, right? It is because see, whenever you call a function, an execution context will definitely be created. But it is different in case when you call it like this in line number 11, and it is different when you call like line number 12. It's different. And the value of this inside those execution context also changes, also differs. Right? So this is what we have seen so far. Now, let me take more examples to tell you a little more complex things, what are happening, right? So suppose if this is an object, right? If the property, let's not keep the property like this, but what if I just take that function x and put it inside as a proper property here, right? X function here, and I call obj.x. The output will be same, the obj, right? But now let's do more crazy thing. Let's create one more function inside this method x, right? Let's create a function even inside x. Let's call it y. Let's give it a variable also. Let me give it as 30, and let's do a console log inside this. What do you think the output will be? And let me also call it definitely, right? So, yep. So if I call this function y, what do you think the output will be? So over here, this will point to obj, right? What will this point to? Huh?
Window.
Yep. So some people say obj, some people say window. So let's run and reveal the mystery out. So the first one prints the object and the second one prints window. How come? It's weird, right? I mean, that's the reason like people hate JavaScript, right? But no, let's see what is happening behind the scenes. Okay, so let me put a debugger and see what happened. If we go inside this and if I put a debugger inside y, so see, now you see the call stack, how it behaves, okay? So if I refresh the page, see the call stack here. The bottom of the call stack has anonymous, which is the global execution context. And then comes the execution context of x. And then comes the execution context of y. The control is right now at line number 9. Right? So each of these execution contexts will have its own reference of this. So this keyword over here in y points to window, and this keyword over here in x points to this object. Here you can see that. So what we have understood is, right, and what we generally assume is, right, it is a very big myth which I want to break right now. A lot of developers only gets confused because they think that the value of this depends on where the function lexically sits inside the code. We feel that, okay, if that function is inside that object anywhere in the hierarchy, this would refer to obj, but that's not true. What is true then? So let me repeat that statement once again. Many people think that, okay, the value of this is dependent on where the function sits lexically inside the code, but it is not true. That is what our human mind thinks of. What is true is that the value of this depends on how your function is being called. Okay, how your function is being called, and it happens on runtime. And that's why this concept is also known as runtime binding. Okay, so it's known as runtime binding, right? At the runtime, right? And once an execution context is created and a this keyword is created, now the value of this you cannot change it later in the code. You cannot. It's not in our control. So this is known as runtime binding, and that's why the functions behave the way it behaves. Now you'll ask me, okay, then if it is so random, then how would we know what will the value of this be, right? It's very random. But no, it's easy. It's easier than it looks like. So basically, when I say that it depends on how that function is being called, right? So if the function is a property of an object, if it's a method, then the value of this is the current object. And if the function is called normally, right? Normally, like how we call y, right? If it is called normally, whether it is inside the hierarchy or outside the global scope, wherever, it always points to window. So these are the two things, right? So that's how it is. And let's okay. So if I like copy this function and put it outside, right? Same function. So if I run this, here this will point to window, right? And even if you call it inside, it's the same way. It depends on how you call the function and not on where it lexically sits inside the code. This is a subtle difference which we need to understand, right? So now let's take, so now we got to know, okay, what this could be, right? We can see a program and can tell, okay, what this could be. And we also saw that, okay, it's very random. Now if random things happen, then how would we know whether we are writing good code or not? So in JavaScript, we also have a way where we can take command over this keyword. We can decide for our execution context what this should be. And how do we do that? Any guesses? Yep. I heard the word bind, right? So you can do that by bind, by call, by apply. These are three methods on function.prototype which are provided again by JavaScript itself, right? To control or to take the command of this. Let's see how we can do that quickly with the code, right? So if suppose, let's take another example now, okay? Suppose if we have user1, right? And we have, I'm taking a very genuine use case, like we generally code, how we generally code. First name is Akshay, okay? And suppose there is a method print name. Okay, and it just logs this dot first name. Okay, so now what will happen is, let me just pull it here. Yep. So now what will happen is, if I do a user1 dot print name, right, it will print Akshay, right? This is very simple. But suppose there is a use case where, suppose if we have one more object which is very similar to user1, let's call it as user2, right? It's again an object, and over here let's take the first name as Simran. Okay, so now again we have to suppose print this name. What would we do? So some developers, what they do is they just copy paste and then sneak in here. A lot of people do that, isn't it? But what is the number one rule of programming? DRY. Don't repeat yourself, right? So whenever you say something, you are repeating, right? We are repeating the exact behavior of print name in both the cases. So I have seen a lot of such code in production too, but this is not we should write, right? So basically, a better way would be to extract this print name outside, isn't it? And now you will see that where this keyword would be very much helpful, right? If suppose if I extracted this function out, print name, and I want to reuse this method into both the objects, how would I do that? Right? I wanted, okay, now this function is outside, right? Can you guess what the this over here in the function would be if I call it like this. See, now we have kept it outside, right? If I just call this function, what would the this would be? Window. Yep. Right? So if I print this, this would be, oh come on, what happened? Yep, okay, print this dot first name, right? So window does not have a first name, so it prints undefined, but if I print in this, right, it is window. So now if I want to use this print name with both these objects, right? So how we can do that? So for that, we will need to take command over this keyword inside that function. So that means when JavaScript engine is creating an execution context for this function print name, right? We would need a control over this keyword, that what should this keyword be, right? When I am calling for user1, this keyword should refer to user1 or user2. So for that, as people said, we can use call, apply or bind. Let me just quickly show you by using call here, right? If I use the function call, JavaScript gives us access to this method call. Here you can explicitly tell the JavaScript engine that now I want my this to be this, right? User1. So if I call this print name using user1, so, and similarly for user2, this will work. Let's see. So now I log this, right? So if I do a this dot first name, they will give you the exact result which I want. So basically this is the way. So what we learned so far? We learned that okay, behavior of this is very dynamic, right? And now we wanted to take control of it. So we can use call, apply and bind to do that. Isn't it? So now what else we can do? Right? What else is the use of this keyword? One more thing is for constructor functions. One more way how we code is, suppose if we create a constructor function, user, right? So, and now I want this user constructor function should have multiple instances. So here you can use this keyword like this. First name is equal to first name. Right? The syntax is very much similar to the classes, right? When we use class, and similarly we can have it is a much more better way to write than the previous one, isn't it? And we can have a function, right? And over here we can have a console.log of this dot first name. So now when you create an instance of this user object, right? So what happens? So in this case of constructor functions, we use a special keyword. What is that special keyword? Can somebody tell? New user, right? So when we use this keyword new, right, it creates an empty object, right? It creates an empty object, and this keyword is then used to set properties and methods over that instance. Nice, right? So if we give over here a name Akshay, right? So it gives me an object in user1, right? If I print user1, it gives me an object in user1, right? And that object has methods and properties which we can set it like this. Amazing, isn't it? And we can do the same for any other places, right? So this is how we can use. This is one more way of using this function, and very important, right? Another function which you might have seen in a lot of libraries is method chaining. Have you seen method chaining sometime, right? What do we do generally is, so suppose if I have to do user1.println, right? So I can print it up, right? It prints Akshay. Let me get rid of this right now. Okay, print name. But you might have seen that, okay, we do a lot of method chaining in a lot of libraries. It is possible that we chain these methods. I can call .print name, .print name, .print name, isn't it? We have seen somewhere, right? How can we implement that? Yeah. We need to basically return this here. So if we return this over here, then we can just keep on chaining these functions. Cool. So these are the major things, right? Which we can do. These are cool things, right? So when you do this, right, it keeps the reference of the current object, right? And you can just chain it infinite time. So this happens behind the scenes. If you just again, like, I mean, go back to your home or place wherever you are coming from, take out your laptop and definitely try all these things yourself. You would love it. And just go to the, you know, we don't do that much. Okay, go to the sources, put a debugger somewhere and see what is happening behind the scenes. I don't see a lot of developers doing this. They don't even know what happens inside sources. So I would request you all to, whenever you get time, go and check what is happening, put breakpoints and see how that call stack works, how execution context works, how this keyword is being set, see, in the local memory space. This is very important being a web developer or if you are coding in JavaScript. Very important. So I think we are, like, I mean, I have taken enough time already, but let's quickly just revise whatever we studied so far, right? I can take a full-fledged a whole day session over this, so many things to cover, but I think this is a good introductory part, okay? So let's quickly revise whatever we have studied so far. So important things to take away from this session or the revision kind of was, first of all, the value of this is dependent on how the function is called, the runtime binding, and not how lexically, where it is lexically present inside the code. It is not dependent on that, right? The first lesson. The second one is, if it's a normal function call, then probably your this keyword refers to the global object, which could be window in case of browser, and it could be global in case of node, and anything like the global object, right? And then I also covered that, okay, now we know that this is so dynamic, we don't know what is happening behind the scenes. So can we take charge or can we take control of this? Yes, there are ways to do that. And the ways could be call, apply and bind method, right? For those who haven't tried it, go back and obviously try the apply and bind method too, okay? And the other thing is constructor functions, right? Using the new keyword, we can create instances of constructor functions, right? That's one more thing that we covered. So with this, thank you so much for joining, right? And you can connect with me on Twitter, Instagram, or whatever social media you use. My handle is AkshayMath7. Thank you for coming, and it was nice having you here. Yep. Bye-bye.
Awesome. Amazing. Thank you. Thank you, Akshay. Thank you so much for the amazing session.